Hello. In this video, we are going to be going over some trigonometry. More specifically, we're going to try and figure out how to solve problems where we have to find the trigonometric function of an angle which is greater than 90 degrees. Because in terms of right angled triangles, it only makes sense to really consider angles A and B which are less than 90 degrees. What does it mean to find, say, the cosine of B where B isn't in this sort of system? Well, here, let's try and answer this. So here we have an example. What is the cosine of 150 degrees? Um, Here we just need to remember that in terms of our unit circle definition, where we have a radius of 1 because it's a radius for unit circle is defined as being a circle with radius of a unit, which is 1. Say we have a vector here or a point on this circle that is extended by an arbitrary angle theta. Well, by trigonometry, we can imagine this as being a right-angled triangle here. We say that the sine of theta is the opposite of the hypotenuse, so this is your opposite, and this is your adjacent. We can rearrange this, and we get this here, but since h is the hypotenuse is 1, that really just says that sine of theta is equal to your opposite side. And then same thing goes with your cosine here. We get that the cos of theta is equal to your adjacent. So what I think is a really important frame of thinking is to be able to apply the unit circle in terms of Cartesian planes. So we imagine that this is a circle centered at the origin on the xy plane here. So therefore, the opposite side of this right angle triangle here, opposite, this actually represents your distance in the vertical. So this opposite gives you the vertical component of this point here. And then the cosine, which gives you adjacent, is actually going to be your horizontal distance. So if we say that's our origin, so that's 0, 0 here, then this will be our horizontal distance and this will be our vertical distance. The reason why we employ this frame of thinking is because oftentimes in, engineering and physical problems, you can't necessarily map a body in terms of its horizontal and vertical distance. You would actually need to represent it as a function of its distance and angle. So if you've got a body that's spinning around the origin, you represent it in terms of its angle and its magnitude. So that is what we denote as polar coordinates. You don't have to worry too much about that. That's just going into the nitty-gritty subtleties of these problems. So using this thinking here, we say that the angle 150 degrees, we can write this like this because this angle here has to be 90. Therefore, this angle here is 180. Therefore, this angle here has to be 30 because it's a complementary angle of this. Now, if we remember that the cosine of an angle from here is your horizontal distance, we need to find this distance here, right? If we were to project this vector down onto its horizontal, what would be its magnitude? So here, well, we just imagine that we have this right angle triangle here now. So we've got this guy here, that there, 30, hypotenuse 1. Then by trigonometry, this side here, your horizontal, is going to be your cos of 30, right? Because cos of 30 is adjacent over hypotenuse, but your hypotenuse is 1, so then you get this. So cos of 30 by exact values we know as being the square root of 3 on 2. But this isn't the correct answer. Because if this is our origin, then this distance here must be negative, right? Because this is going to be, on the left-hand side of the origin on the Cartesian plane. So our answer is actually this here. And that is sort of, gives proof as to why we denote each quadrant as being this A, S, T, C, because S is positive here because this is positive, but this is negative. And then tangent is positive because both the cosine and the sine, both the sine and the cosine are negative. And tangent is defined as being sine over cosine, negative over negative gives positive. Here, cosine is positive because you're in this part here. So I hope that makes sense. Now, doing another example, let's say sine of 225. This is equal to your sine of 180 plus 45. Now what you can do is you can do, your angle sum identity, where this is going to be sine 180 cos 45 ... But that formula is a little bit redundant in a case like this, because you can just draw this out. This will be this angle here. So this will be 45. And then this whole angle here is 225. So now we're considering this sort of system here. And the sine of any angle will correspond to the vertical distance, so the opposite. So then this is equal to just the sine of 45, which we know is being root 2 over 2. But again, since we are in the third quadrant here, and this distance is actually this one here, and this is negative because we're in an XY frame, then our answer is this root 2 onto negative. So that's sine of 225. I hope that makes sense. Any questions, do leave it in the comments or anything. You know how to reach me, and thank you for watching.